All right. So this week we're going to talk about the CSV module. If you've ever been involved with the Voltron project, you probably have seen that we like to use that project likes to use CSV files wherever it can, along with JSON and other formats. But CSV tends to be popular with when we want to do anything with tabulated data. I think tabulated is the right word. And the reason for that is that Python comes with an excellent CSV module for reading and writing CSV files. So I will go ahead and in the chat, I will post a link to the documentation that I'm working from so that you can follow along. Okay, so if you don't know what the CSV format is, it's a general purpose row-based plain text format for storing the kind of data that you would manipulate in a spreadsheet. Now, the problem with the CSV format is that it is not a standardized format. It took various forms. It was being used widely before it was before anybody attempted to codify it. RFC 4180 attempts to codify the CSV format. But before then, lots of people were using it in different ways. There were different delimiter characters, different ways of escaping the data. But the general format is roughly the same, enough so that there can be one general purpose module for dealing with CSV files in general. But these days, if anybody is talking about CSV files, they're usually referring to Microsoft's version of the CSV format. Now, this is not to say that CSV is a good format per se. It's just that it's easy to use in Python. There are some things about the CSV format that make me a little crazy, like how the method for escaping delimiter characters within a field is to quote the entire field, and then you run into stickiness. Well, how do you escape a quote character within a field, and on and on and on? And it's needlessly complicated. There are much easier ways to do the exact same thing. But it's a very popular format. Excel reads and writes it very seamlessly, and so it becomes very useful for getting data from, like, say, engineers who are familiar with Excel. And say, well, yeah, build up the data in Excel, and then we will read it in and just save it to CSV, and then we'll deal with it in Python. So, fortunately, the irritants of working with the format are all handled for us with the CSV module. So let's write a simple example CSV file. So this is a CSV file with one row. It has no and that's it. There's really nothing that it has one row with 3 columns, and that's it. There's nothing about the format that declares, like, the first row a header or anything like that. You just have to know how to interpret the file. So you have to know a little something about the CSV file in order to be able to process it properly. So let's go ahead and add in a second row. Okay, and there's our CSV file. So it's called example CSV. So let's go ahead and write a script to import this file and read it and print out the contents. So we're going to go import CSV, and then we need to open the file. We need to open the file and get a file-like object to hand off to our CSV reader. So we would do with open, and then let's see, it's example.csv. And then where it matters, we need to on platforms where it actually matters, we need to read the file as a bytes file. So we're going to set the we're going to do read bytes. Now, I'm noticing in the examples for Python 3 that it does not include the bytes qualifier. I'm not sure why that is. I know that in Python 2 it's required. If you don't include it, it screws up the new lines in the file. Especially, I think, when you go to write it back out. If you don't specify bytes, it will. In fact, that's probably what it is. If you read, it's unnecessary. If you're writing, I think you need to include the bytes. But if you don't, you get like erroneous blank lines in your resulting file. But that's in Python 2. I think they might have fixed it in Python 3. So let's just go with what they show in the example. So as f. And then we are going to create a reader object. So we'll call it r equals CSV reader. And then we pass it our file. And that's it. So the default reader will read the Microsoft style CSV file. In fact, I've done something erroneous here is I put spaces after the commas, and that would actually put spaces in my field. So I need to take those out. All right. So now we have a reader that will read a bog standard CSV file. We can also specify if we need to override the behavior of how to interpret the CSV file, we can specify like things like the delimiter, limiter, and then we pass it a string that we tell it what we want the delimiter to be. So we could do like a delimiter of space. In this case, our delimiter is a comma, but this is unnecessary because the default delimiter is a comma. How do we quote fields for escaping delimiters? So that would be, we can change that with quote, char equals, and then the default quote character is the double quote, but we could change it to something like a vertical bar or something like that. But since these are the defaults, we don't have to specify them, so we'll go ahead and take those out. Okay, then what we can do is, so the reader is an iterable object that we can step over and get the rows out. So we can do for row in reader print, and then let's just print the row verbatim so that we can see the data types that it's actually returning. So if we go ahead and execute this guy, we get two lists printed out. The first row has the elements of the first list, and the second row has the elements of the second row. In is a list of the elements in the second row, and so it's pretty straightforward. We don't have to worry about the commas. We don't have to. So if we did something like that, it would automatically handle the escaping and put that all into a single field on its own. So if we run this, our second element of our first row has, it includes a comma. So it handles all of that for us. So let's look at another example here. And what we'll do is we will go ahead, I'll go ahead and strip this out. A more common use case is oftentimes CSV files will have a header row, and the header row basically tells us, gives us context for each column in our CSV file. So the way that we do that is we use what's called a dict reader. So a dict reader is just what it sounds like, dict reader. And again, we just pass in the same file object. And but now in our reader, instead of returning lists for each row, it uses the first row to define headers. And instead of returning a list, it returns a dictionary. So let's go ahead and run this and see what happens. So, oh, and it's even an ordered dict. That's awesome. Oh, I forgot to save that. Let's run that again. There we go. It's more what I was expecting. So the second time we loop through it, we only get one row because it read our first row as header data. And so now instead of getting individual rows that we have to work out the context ourselves, we get a dictionary of key value pairs. And in this case, it's returning an ordered dict, so it's returning the so that it makes sure that it returns the columns in the appropriate order. But in like the Python 2 version, it would just return a plain dictionary. But it's here nor there. You're usually just going to be looking up the columns by name. The nice thing about this is then if you change the order of your columns, but you have a header row, you can just keep referring to particular columns by their name as you iterate through it. So this is the more common way that you'll see the dict reader used. Okay. So that's reading, and that's pretty straightforward. Okay. Touch. Example. Okay, so I just created a file called write example. And write example, we're going to work through some examples of writing instead of reading. So I'll go ahead and copy this guy over here so we don't have to rewrite the whole thing. Okay, so now we've been doing reading, so let's do some writing. Write example. So if we want to create a CSV file, it's the same thing except that instead of a read file object, we create a write file object. And instead of a reader, we create a writer. The rules are all the same. You can specify the delimiter, you can specify the quote characters, and anything like that, and it will produce a CSV file that follows the rules that you specify for your quote characters and your delimiters when you create it. So for fun, let's go ahead and change the delimiter and the quote character to a space and a bar. Okay. So what this gives us back is a writer object. So this is not something that we can iterate over, but instead we can write rows. So since there's no limit on how many columns that we can have or per rows, this is basically just an open format. Just write the rows that you want and it will just do it. So let's give ourselves a couple of rows here to write. And I'll change these names to match our example here. Okay, so now what we're going to do is we're just opening up a writer, and the writer expects a list of values to go in to a particular row. So in this case, we're writing spam 5 times and then baked beans at the end. and then we've got another row with 3 elements in it, so we've got spaces in here. So this is also a good example. We've got spaces in our elements, so we'll use our quote character and our it'll show us how it'll automatically quote the delimiter when necessary. So let's go ahead and run this. What did I do? CSV has writer. There we go. Let's try that again. There. So then if we go like this, view, let's see. I want it to show the project pane, and I hit it and then I forgot. Now I forget how to get it back. Nuts. Oh, nuts. Okay. We'll just open this by hand then. CSV. Right example CSV. There we go. Okay. So now we've got the CSV file that we've written out, and because baked beans has a space in it, it's quoted by our quote character, which is vertical bar. Same thing with our lovely spam and wonderful spam at the end. So we can go ahead and change this. If we change our delimiter back to a comma, save this and run it. Now all of our everything gets replaced by commas, and now nothing is quoted anymore. Okay. So now let's do another example. And I'm just going to copy their example verbatim because it's kind of involved, but it's a good example. Oh, you know what? They're not writing bytes, but they're setting new line to an empty string. And I wonder if that's what handles the new line issue in Python 3. I just noticed that now with the examples that they've been giving. So, Brandon, are you familiar with the new line argument to open in Python 3?
I think it has to do with the automatic new line handling. I forget what they call that feature specifically.
Yeah, okay. Because I remember in Python 2, if you were attempting to write a CSV file and you didn't specify bytes when you created the file object, you would get the superfluous empty lines. Do you remember that problem?
No, I don't.
Okay, it must be something that I ran into. But yeah, if you didn't specify WB, your output would oftentimes be wrong.
Oh,
So
universal new lines. That's the name of the feature.
universal new. Okay. All right. Yeah, because there is. Oh, because that's important. So part of the CSV file format, and this really gets to the heart of the issue. Part of the CSV file format, the official CSV file format, is it specifies how new lines are supposed to be created, and I believe it follows the Windows DOS standard. So Unix line endings are not I don't believe are technically correct for CSV files, and that's where you get the superfluous empty lines. Is if you don't tell it, hey, we're gonna we're gonna read bytes, so we want to deal with the CSV module wants to deal with the new lines itself. So okay, so now we're going to create a dictionary writer, and we'll just use its example for names CSV. We're creating a write file. It's a CSV file. And what is it complaining about? Inward CS. Oh, it's a typo. Okay. So when we create a dictionary writer, the first thing that we have to do is specify our column names. And in this case, they call it field names. We are going to, we pass it in our file object. we pass in our field names, and then what we have to explicitly tell it to write the header, so that it does not, when you go to create this, when you go to write the file, it does not write the header automatically. So this way you could actually create a CSV file that doesn't have a header, but you're giving the different columns names, so that you don't have to worry about creating a list with the elements in the right order. So we write our header, and then we write our rows, and instead of passing it a list, then we start passing, we pass it a dictionary, and the dictionary says, is just field name to value mapping. And that's really all there is to it. This makes it very simple to write a CSV file. So let's go ahead and run this. And we'll go ahead and open our name CSV. And so now we have our header row. And then we have the values that we passed in. Oh, there's my project tab. Ugh. Adam, I swear. Okay. So now it's got all three of our rows and our header in the order written. So yeah, there are a couple of features that are kind of special use cases for CSV files, but what we've gone through here will handle 99% of the cases. There are some special things for like handling like when if you don't specify all of your fields when you're writing to a dictionary. There's when you create the writer, there's additional arguments for handling missing elements or handling extra elements. The reader, the dict reader, also has additional things for what do you do with like if you have more elements than you have actually have fields for when it read the header, and how it handles that. So there are edge case handling for things like that, but that's I mean that's outside of the scope of this presentation. So that's the CSV file and module in a nutshell. We find it very handy. We use it and abuse it all the time. Both when I was on the Voltron project, we used it everywhere. And my current employer, we use it a lot as well, because it's just handy way for dealing with basically spreadsheet like data. Are there any questions? Okay, if not, we'll call it a meeting unless there are general questions regarding Python.
I have input.
Yeah.
There's another cool feature of this module, which is the sniffer.
Oh yeah, that's right. I forgot about that guy.
Yeah, where you can read like a chunk of data in from a file and then pass it into the sniffer, and it will create a dialect object, which you can then pass into the reader. So it's usually pretty good about being able to determine what the delimiter and the quoting style, line endings, and
Yeah.
that sort of thing. And what we discovered recently too is that you can sniff and get that dialect and pass that into Panda's CSV reader as well.
Oh. Yeah, so for those of you who don't know, Pandas is a library for dealing with column oriented data, but it has its own CSV reader that's a little bit more sophisticated than the Python the standard library CSV reader. So one of the things that you may or may not have noticed is that this CSV reader in Python doesn't make any attempt to infer the type of data from what you read. You just get strings. And so if one of those columns actually happens to represent an integer, you need to transform that into an integer yourself. The Panda CSV reader is sophisticated enough to detect integers and timestamps and lots of other stuff and turn it into the right data type automatically. And so the fact, but I don't know what its limitations are as far as dealing with different formats. But now, as Brandon's informed me, you can teach it to use a different dialect for interpreting the actual CSV format itself before it does its type inference magic. So that's cool. Thanks, Brandon. Yeah, we used the sniffer on what project was that at PNNL that we used the sniffer on? OpenEIS. Is there a nice way to? Okay, so Jay Bigler asks, is there a nice way to read write multiple lines at a time to try and reduce I/O requests? So something that file objects do automatically in Python is, and Brandon, you can jump in here and correct me if I'm wrong, but whenever you write to a file object, it has a buffer that is flushed periodically. So that's just a general mechanism that Python has to reduce I/O. And then when the interpreter closes, it automatically flushes the buffer itself. So there's that. If you go ahead.
I was just saying it does the same for reading.
Yeah, and it does. Yeah, it does the same for reading. I mean, if you feel the need to take it into your own hands for your file object, you could use a string IO object, build that up in memory, and then dump it all to a file all at once. But that's probably not going to be necessary most of the time. So yeah.
And I think people are normally actually more concerned about writing at the end of a line, making sure that it gets flushed when you write a new line. And I believe there's something in the CSV writer that allows that to happen.
To automatically flush lines.
Yeah, I don't remember if it was part of the CSV writer or part of the file itself, the file object.
Okay.
There's a way to get it to force flushes on new lines.
Okay.
I would add that so we use this module as well as the JSON module a lot to process spreadsheet data, CSV data, and then post it to various pages automatically. And one of the slowest, or one of the biggest slowdowns that we experienced was when we echoed the data to the screen, and by turning off all the prints, the speed up was quite good.
Yeah, and it's really and then the question becomes, where's that print going to? Because if it's like going over an SSH session, it slows things way down. but then like, even if everything's on the local machine, you'll run into weird things like, say and I'm going to use an example from Windows because it's one that I can speak authoritatively on. If you ran your thing in a command prompt, like a native command prompt in Windows, the overhead for the print statements was actually pretty negligible, even if there were a lot of them, because it could just Windows could the native command prompt could just churn through those print statements really, really quickly. But then if you ran it like in a debugger in Eclipse using the PyDev module, the output, taking that same print statements and outputting them to the window in the IDE was like orders of magnitude slower than it was in the command prompt, to the point where, like what Casey was saying, you would see a substantial performance hit. So that's a thing that actually happens. All right. Are there any other questions? Comments? Okay. If not, we'll call it a meeting. Thanks everybody for coming out. Thanks for the help, Brandon.